students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as semiconductor. Now let's see how does a PN junction diode work. Let's see a PN junction diode in forward bias. You have the P-type semiconductor here, N-type semiconductor here. Connect this to a battery and a milliamp meter. Right here, your majority carrier in P-type semiconductor is going to be holes. The majority carrier in N-type semiconductors is going to be electrons. Right? Now, let us see how a PN junction diode works. Now, when an external voltage is applied to a PN junction diode in such a way that, in such a direction that it cancels the potential barrier and permits the current to flow, then it is said to be in forward bias. First of all, let us understand what is forward bias. You are going to connect the external voltage in such a way that the potential barrier is going to be overcome and current is going to flow through the diode, then that is called as forward bias. So when external voltage is applied to PN junction in such a way or in such a direction that it cancels the potential barrier and permits current flow. There is an external voltage is applied to PN junction diode in such a direction that it cancels the potential barrier and permits current flow, is called forward bias. Fine, do we get this? Now, how does the diode behave when it is forward bias? Now, to apply forward bias, you connect the positive terminal of the battery to the P-type semiconductor and the negative terminal of the battery to the N-type semiconductor. Right? Now, the applied forward potential establishes an electric field which acts against the field of the potential barrier. That means you would have, since the P-type semiconductor is connected to the positive terminal will exert a repulsive force on the P-type semiconductor, which in turn will exert a force on the potential barrier. Similarly, the N-type semiconductor is connected to the negative terminal. The negative terminal will exert a repulsive force on the N-type semiconductor, which in turn will exert a force on the potential barrier. There would be, once sufficient force is exerted from both the sides on the potential barrier, the electrons would then acquire sufficient energy to overcome the potential barrier, and then once the electrons acquire that energy, they will jump into the holes, will start moving from one hole to another hole and reach the positive terminal, and thus current will flow through the diode.
Just aiming at the part from where the electrons overcome.
See, once the electrons overcome the potential barrier, this electron, we know that opposite charges attract, so the electron will jump into the first adjoining hole. From there it will jump into the next adjoining hole, next, and will reach the positive terminal.
The potential difference applied charges the electrons in.
The potential difference applied to the PN junction gives electrons sufficient energy so that they can overcome the potential barrier. Fine, do you get this thing clear? Right? Let's write this down. To apply forward bias, positive terminal of the battery, is connected to P region, and negative terminal is connected to N region. Positive terminal is connected to the P region and negative terminal is connected to the N region. The applied forward potential establishes an electric field which acts against the field of the potential barrier. Establishes an electric field which acts against the field of the potential barrier. Hence the potential barrier is reduced. Right? Now, as it is small, a small forward voltage completely eliminates the barrier. As the potential barrier is small, a small forward voltage completely eliminates the barrier. Right? Now, here the holes from the P-type are repelled by the positive terminal of the battery and driven towards the junction. The holes from the P-type are repelled by the positive terminal. The holes from the P-type are repelled by the positive terminal of the battery and are repelled by the battery and are driven towards the junction. They cross the junction and move into the N-type and are attracted. They cross the junction, move to the N-type, and are attracted towards the negative terminals of the cell. Similarly, the electrons in the N-type go to the P-type. Go to P-type. p-type and are attracted towards the positive terminal, right? Now, as holes are positive charge carrier, the direction of the current is the same as the conventional current. As holes are positive charge carriers, the direction of hole current is same. The direction of hole current is same as that of conventional current. Is same as that of conventional current. Is same as that of conventional current, right? Now, when a sufficient forward bias is applied, the potential barrier is eliminated and the junction resistance becomes almost zero. Thus, a continuous current flows through the circuit. Fine. So this is how you would forward bias a PN junction. Fine. Next, let's see how do you reverse bias of PN junction. PN junction reverse biased. This is P-type semiconductor. This is my N-type semiconductor. Holes are the majority carriers in P-type semiconductor. Electrons are the majority carriers in N-type semiconductor. Right? Now, what do you mean by reverse bias? When the external potential is applied in such a way that it increases the potential barrier, between PN junctions, and that is called as reverse bias. How do you do reverse bias? In reverse bias, the negative terminal of the battery is connected to the P-type semiconductor and the positive terminal of the battery is connected to the N-type semiconductor. Right? This sets up an electric field which increases the potential barrier. The negative terminal of the battery attracts the holes towards itself, hence the holes start moving away from the barrier. Similarly, the positive terminal of the battery attracts the electrons towards itself, therefore the electrons also start moving away from the barrier, which causes the width of the barrier or the depletion layer to increase. The size of the depletion layer increases. Moreover, no current flows, no charge particle flows through the diode, right? And hence here the diode behaves like an insulator, right? The resistance of the diode increases and the diode behaves like an insulator, and that is called as reverse bias. Fine, do you understand this? Let's write this down quickly. When external voltage is applied to PN junction in such a way that it cancels the potential, that it increases the potential barrier it increases the potential barrier and does not permit current flow it is called as reverse bias, right? To apply reverse bias, the positive terminal of the battery is connected to N-type and the negative terminal of the battery is connected to P-type. Fine. The applied reverse or backward potential establishes an electric field which acts in the direction of the field and increases the size of the potential barrier. Right? So I can say that the applied reverse voltage establishes an electric field which acts in the same direction as the field that is as the potential barrier field due to the potential barrier. Right? Therefore, the resultant field at the junction is strengthened. Therefore, the resultant field at the junction is strengthened and the barrier increases in size, which prevents the flow of charge across the junction, carriers across the junction, Thus, a high resistance path is established in the entire circuit. For the circuit. A high resistance path established. In reverse bias, the electrons from the N-type and the holes from the P-type are attracted away from the junction. In reverse bias, the electrons from N-type and holes from P-type are attracted away from the junction. they are attracted away from the junction. Right? Since there is no recombination of electron hole pair, ideally no current flows through the circuit. Since there is no recombination of electron hole pairs, recombination of electron hole pair, since there is no recombination of electron hole pairs, therefore no current flows through the circuit. Flows through the circuit. Right? Do we get this thing here? Now, what we understand from here is that a PN junction can either be forward bias. If it is forward bias, its resistance will be very low, hence entire current will flow through the path. On the other hand, if it is reverse bias, its resistance will be very high and no current will flow through the path. In both the cases, what we realize is that the current flows through the path only in one direction. The PN junction allows current to flow only in one direction, and a device that allows current to flow only in one direction is called as diode, and hence a PN junction is called as diode. A PN junction is called as diode because it allows the flow of current only in one direction. Right? Why do I need to use semiconductors? Let's see what are the advantages of semiconductors. Advantages of semiconductors. Right? First, they occupy very less space. Right? Today we have integrated circuits which contain millions of components in a very small space, so that different complex operations can be performed by a very small circuit. So the first advantage of using semiconductor is they are very small. They are very small and occupy less space. Right? Next, they are light and have small weight as comparison to vacuum tube. They are extremely light in terms of weight. Right? They are light, or I can say have small weight. Next, they do not require heating. There is no heating element in this. Do not require heating. Right? Next, they have low operating voltage. Have low operating voltage. Right? They consume less power. Right? They can work on extremely small amount of power. Consume less power. Fine. They have long operating life. Operating life. Fine. And they are instantaneous. They start immediately. Instantaneous. These are the advantages of semiconductors. What are the disadvantages of semiconductors? They cannot handle high powers and hence they are not suitable for high voltage applications. Disadvantages. Not suitable for high voltage application. Suitable for high voltage application. They are not suitable for high voltage application. They are sensitive to the change in temperature and radiations. Right? Sensitive to to change in temperature and radiations. So they cannot be used in applications where there is a change in temperature or there are radiations that are produced. Right? Okay. We'll stop this here for the day. Thank you very much.